Welcome to Python for Scientific Computing 1. This is the second video on the topic of for loops. In the last video, I provided you an introduction to for loops in Python and how they can be used to work with one-dimensional data structures such as lists. In this video, I'm going to show you how for loops can be used to work with two-dimensional or higher dimensional data. So before we jump into two-dimensional and higher dimensional data, let me start off with this question. The question is, we've seen lists in Python, and I'm sure you have come across what a matrix is in your mathematics classes, and then arrays, which are basically multidimensional matrices. The question then is, are these the same? Are they the same? Are they different? If they are the same, how are they similar? And if they are different, what makes them different? So a list, as you all know, is a native Python data structure. It is a one-dimensional vector of numbers. Since we are dealing with numerical methods, I'm going to call this a vector of numbers. But in reality, a list can hold heterogeneous data. It can hold both strings and numbers and Boolean values as well. But for our purposes here, a list is a one-dimensional vector of numbers because that's what we'll be dealing with in this class. We denote the list using square brackets, and then a list has a set of elements, and those elements are separated by commas. Okay? And a list also is indexed, starting with 0, up to the number of elements. So the first element of a list will have an index of 0, and the last element of a list will have an index that is 1 less than the length of that list. If you want to know the length of a list, you can use the len command in Python to get the length of the list. A matrix is a 2D representation of numbers. You've got rows and columns, and you can perform a wide range of calculations using matrices. Matrices arise in many numerical techniques, regression, machine learning, ODE, PDEs. So having a good grasp of matrices and able to work with matrices using a computer goes a long way in your understanding of both engineering and scientific disciplines that you're interested in. What are arrays? Arrays essentially are enhanced matrices. You can think of arrays as being a sequence of matrices. Arrays play a major role in many emerging applications. For example, there are new data models or data structures such as the hierarchical data format, HDF, or the netCDF, which are being used to disseminate very large data sets. Data arrays help us do integration of both space and time. For example, we can interpolate in both space and time using these types of data. However, this type of data is not new. We've had this type of multidimensional arrays for at least 50 plus years now. The color pictures that you take using your phone these days are nothing but RGB images, are basically an array of 3 different matrices, one having the intensity of red, one having the intensity of green, and one having the intensity of blue. A matrix has rows and columns, or data is along 2 axes. If I were to take multiple such matrices, then I get an array. So I have an axis 0, an axis 1. The axis 0 is rows, axis 1 is columns, and then the axis 2 is the third dimension over which data are stacked. So what I have here is an array, a matrix, and a list. All have numbers, the same numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, but they're all arranged differently. The difference between list, matrix, and array is that they all have different shapes, 1D, 2D, or 3D. And the key difference is just in how these numbers are arranged. What is key to all of these is they're all a sequence of numbers. Therefore, you can recast them from one form to another. In other words, you can take a list, make it into a matrix. You can take a matrix, make it into an array. So you can change the shape, but essentially what you have is a list of numbers. And this is important from the standpoint of how these numbers are to be stored, what type of data structures do we need to work with matrices and arrays, and how do we go from a list to a matrix or a matrix to a list and vice versa. Native Python, in terms of data structures, only offers a list. It doesn't offer us a matrix data structure or an array data structure like some other programming languages do. And this is because Python is a lean language and it does not like to provide functionality that can be derived. So since we know that matrix array are nothing but lists that are rearranged in a different way, the original thinking was that we probably don't need to have matrix and arrays. We can just work with lists. But there are libraries that provide us with matrix and array data structures. We'll be looking at NumPy library in some detail later on in the course. If we look at the mathematical representation versus Python representation in terms of lists, I can define a list, or which is a vector or a 1D matrix, a 2D matrix, and a 3D array, all of them using lists. We all saw how to represent a 1D matrix or a vector of numbers or a sequence of numbers using a list. I have numbers 1 through 12, and they are simply put as a list of numbers. The 2D matrix is also the same list of numbers here, but I have 4 rows and 3 columns. And somehow I have to keep this idea of 4 rows and 3 columns as part of my matrix representation. So what I can do is I can use a list of lists where I'm using 1, 2, 3, which is my row. And these are the column elements of my first row, the column elements of my second row, the column elements of my third row, and the column elements of my fourth row. So I'm creating a list of sublists. Each sublist has the column elements corresponding to a row, and then the outside list essentially is a list of each row. A 2D matrix can be represented using a list of lists. I can extend this logic to create a list of lists to create a 3D array. Of course, if you get into multidimensionals, the number of nesting goes up. And as the number of nesting goes up, it becomes somewhat difficult to keep track of these data structures. What happens when I take a list of lists and pass it through a for loop? So I have a list of lists here. So I have a list, we have A, which is basically a list. It's a list because you see these outer square brackets. And inside that list, there are elements because those elements are separated by commas. But you'll notice that each of the element actually is a list in itself. So there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can think of this as being a matrix with 3 rows and 4 columns. So now if I come out and say for I in A, so I want to loop through A, each element of A, and what I want to do in the code block is simply print the value that it is pulling out for I. I want to see what gets pulled into I when I loop over A. And then once the loop exits, I want to get the length of the list. So I'm going to use the print statement to get the length of the list. Again, I'm using a len of A as my function to do so. So when I loop through this, what it does is I goes and pulls the first element. What element is it pulling? It actually pulls 1, 2, 3, 4, which is the first sublist. Then it goes and pulls 5, 6, 7, 8. Then it pulls 9, 10, 11, 12. And it says the length of the list is 3. Another way to access is to use indices. If I put A of 0, what I see is that I am going to get 1, 2, 3, 4, which is this sublist. If I were to use a second level, and say A of 0 and then put a square bracket of 1, what I want is I want to access the 0th element of my list A, and then I want to access the first element of that sublist. So again, the nesting, it starts with 0, 1, 2, 3. So I'm going to get the value of 2, which is part of the 0th element, and inside the sublist, it is the first element. So 0, 0 would give me 1, 0, 1 would give me 2, 0, 2 would give me 3, and 0, 3 would give me 4. A single loop, what it tells me is that it's not able to access the elements of the sublist. It can access the sublist, but it won't access the individual elements of the sublist. To do that, I need to have another loop. What I want to do here is I want to take a for loop and I want to flatten the list from 2D to 1D. In other words, I have a list that goes like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This has an index of 0. This has an index of 1. This has an index of 2. What I want to do is I want to create a flat list. So I want to go from this 2D structure to 1D structure and essentially have an index from 0 to 11 and then have my numbers, which are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've color coded it to let you know that that is coming from my first index of my list of lists. The 5, 6, 7, 8 are orange color. They're coming from the index 1 of my list of lists. And then the 9, 10, 11, 12 are coming from index 2 of my list of lists. So how do I go about doing it? First, what I need to do is I need to read a list of lists. Clearly, that is the list I want to parse or I want to flatten. And I want to initialize a flat list FL. So I need to create an empty list in which I can store or append these values. And then I'm going to loop over the list of lists. Remember, the list loop starts with an index 0, then goes to 1, this goes to 2. It pulls the first element, 1, 2, 3, 4. And once it pulls this 1, 2, 3, 4, what I want to do is I want to loop over that subgroup of 1, 2, 3, 4, keep appending each of these numbers to that list. And then once this subgroup is done, what I want to do is I want to go back, pull the second subgroup, go down, loop through each of that subgroup, parse the numbers, put them in a list, go back and get the next subgroup, and then parse each of the element. And once that is done, I want to leave the for loop, the nested for loop, and go to the next statement. So if we look at the workflow, we initialize an empty list, we loop through and pull each element from the list of lists, and then each element in a sublist, and then create a second loop through each element of the sublist, and then append the element to a flat list. So I have my list of lists. I labeled it LOL, and here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which are the three elements of my list LOL. So what I do is I initialize. If I print this list, I'm going to see it as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, just the way it was written. Now I initialize an empty flat list, and then I say for L in LOL. Okay, so the first L will go and pull this 1, 2, 3, 4. And then once it pulls this 1, 2, 3, 4, I'm going to say for J in L. Remember, L has, so now J is going to go and pick up 1, J is going to pick up 2, J is going to pick up 3, and J is going to pick up 4. And as it picks up, I want it to go into the loop, append the value of J to X, which is this empty list, and keep moving forward. Next, it goes back and L pulls the second element, which is 5, 6, 7, 8, brings it in. And then what I'm going to do is I'm going to take the J in L and I'm going to parse out 5, 6, 7, 8, and then keep appending it, and then keep moving, and then do 9, 10, 11, 12. Again, keep appending it. At the end, if I print the flat list is X, this X is where I'm appending my values, it'll write the flat list here. Now, how about going from a 1D list to a 2D list? So here's my list of numbers. And what I want to do is I want to put them into a list of 3 rows and 4 columns. So to do this, what I want to do is I want to create the sublist 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is what I'm going to be doing inside the loop. And then in the outside loop, I keep appending these values to the main list, so that's what the outside loop does. The logic of this in terms of a flowchart, what I want to do is I want to first read the flat list. This is the numbers from 1 through 12. This is my list. I want to state or read the number of rows that I want. Here I have 3 rows, and I want to read the number of columns, which is equal to 4. Number of rows, n rows times n columns should be equal to the number of elements of that list. Otherwise, this will not work, right? So then I want to initialize a list of lists. This is the two-dimensional list that I want to create. So I'm going to initialize it as an empty list. And I'm also going to initialize an index to be equal to 0. Then what I do is I loop through number of rows. So the number of rows, or the index of the number of rows, is what? It goes from 0, 1, and 2. And then what I do is I go into my index 0, or the first row. I initialize a sublist, because in this sublist I'm going to write the first 4 elements, which are the columns. So I go in to J, and then I keep pulling my values from my flat list using this index, write it to the sublist, update my index, and keep looping it. So once the 4 elements are written, then it'll go back up again. It has appended that sublist to the list of lists, goes back, goes to the next row, and in the next row it again creates a new sublist for it to add the data. Then I loop over 4 times, and I take the values, the next 4 values, append it to the sublist, and then append that sublist to the list of lists, and I move forward. Okay, so here's the list of lists. I loop through first. I go, and the first one I create this list of lists, and then I fill it up with these 4 numbers. Then I loop back, create a new sublist, and then fill these 4 numbers, and then as a sublist, and then loop again, fill out the last 4 numbers, and then end my calculations. So the workflow logic and the code here, I've created a list of numbers, and if I put the original list A, you're seeing that it's a one-dimensional list. Now I want to split that into 3 rows and 4 columns. So to do that, I need to create the indices. The row is the index. This lowercase row is the index. And the index goes from 0 to n row. Since I have not given a step size, it goes in increments of 1. N row is 3, which means it's going to create 0, 1, 2 as the elements of the range. Remember, the first one is inclusive, second number is exclusive. Similarly for columns ncol is 4, so it's going to go from 0, 1, 2, 3. Next, I have incremented the index. This index is what I'll be using to pull numbers from my original list. Okay. So I have to sequentially move from 1 through 12 as I'm pulling the right number to fill into the list. So first I loop over the rows. The rows are going from 0, 1, 2. So I starts at 0. I initialize an empty list. And for J in column, so J goes from 0, 1, 2, 3. What I'm going to do is Z is A of IDX. My IDX is 0. So it pulls the element that has an index of 0, which is 1, appends it, updates my index by 1, goes back, J goes from 0 to 1, and then A of 1 is what I pick, which is 2, and then update it again to 2, get that number, and keep doing till I get all the way to 12. What is the outside loop doing? The outside loop does 2 things. One, it initializes an empty list for the columns to be put in. And once that's done, it appends it to my list of lists. It takes that sublist that I just created and appends it back to my list of lists where I want to put in. So the outside loop is doing 2 things. It always gives me an empty list, empty sublist to fill it out. The inside loop is filling that sublist, and then once the sublist is filled, it will go and append that sublist of 1, 2, 3, 4 to my main list, which is the list of lists. I'll admit, working with nested lists is not intuitive. We do have some libraries which will make our lives easier, but it's always important for you to see how these calculations are made so that you have a good grasp of what the libraries are trying to do internally. NumPy is one such library that we'll be looking at. NumPy stands for numerical Python, and NumPy gives us a variety of different objects, such as the 1D array, the 2D array, and the 3D array, which we can use to store lists, matrices, and arrays, multidimensional arrays, and we can reshape them from one way to another so making our calculations much easier. So in summary, native Python only provides us with a list. If you want to get 2D and 3D matrices, which are important for a wide range of applications, you have to create these data sets by nesting lists. So that concludes this lecture. I will see you in the next lecture. Till then, take care and goodbye.